Hello students. Today we are doing actually another series from optics. Actually, when we are doing lessons, actually we need to remember the equations from the lessons, right? So, for example, you get a question and you don't know how to do the question. That's a different story. But still, you get the idea how to do the question, but still you don't know the equation. So, if you do not know the equation, you cannot proceed. So our solution here is that we are going to remind you all the equations that you are going to get in optics lesson. So just go through with this video and you will learn almost all the equations you need to do. You need to remember actually when doing questions. So write it down, try to remember, then write down it again and again. And if you practice this properly, you will remember the equations, right? So when you are doing questions, then you can apply the equations. Right. Let's see. Just check whether there are new equations for sure. But remember that you have to remember all of these, almost all of these equations, if you need to get the questions done right. Right. Let's get to the video now. Optics. Right. Today we are writing optics equations. Basically, there are three types of lessons, three types of categories in optics. So we are moving into that. First we have refraction, and in the second phase we have lenses, and finally we have prisms. Right. So let's start with refraction, then move into lenses, and finally let's move into prisms. Right, in refraction, actually here now let's take, this is first medium and this is the second medium, n2. So refractive index n2 over n1 equals sine I over sine r. You should know what is sine I and sine r, and of course n2 is the second medium, n1 is the first medium, right? And connecting all these equations, we have n2 over n1 equals sine I over sine r and c1 over c2. Here c1 is velocity of light in first medium and c2 is velocity of light in second medium, right? Moving into critical angle equation. So here I is critical angle and this angle is 90. So let's write the normal equation, n2 over n1 equals sine I over sine r. Here sine I is sine c and sine r is sine 90. So basically the equation becomes n2 over n1 equals sine c. Should know this equation as well. Apparent depth, real depth equation. Here first medium, we have the object in this medium, so it's first medium and this is the second medium. So our normal equation n2 over n1 equals apparent depth over real depth. That's the equation. Now there's another equation, the difference between real depth and the apparent depth, we call it apparent shift, d. For that, of course, we can write another equation, d equals t into, t is actually here the thickness of the medium, so here basically it's equal to real depth, t1 minus n2 over n1. T is the thickness of the medium, or you can take it as the real depth. Lenses. Under lenses we have convex lenses, and of course we have convex lenses and we have concave lenses. Here the focal length is this, parallel rays will converge here and parallel rays will converge. It's almost like it is starting from this point, it's focal length here now, right? Power of lenses, P equals minus 1 over f. F is focal length, but in meters. Remember that the unit will be diopters. Moving into lens formula. Lens formula, it's 1 over v minus 1 over u equals 1 over f. but when applying lens formula, actually we need to apply sign convention when putting values actually for this. So sign convention will be something like this, right? Sign convention is this. Now the object is here. This is the object, right? The light actually comes from the object. VSC of light comes from the object. So this is the direction of light. Direction of light. So any distance measured towards the direction of light. Let's say the V here. V is the image distance. So we measure it from the center here up to this level. This is the distance, right? So we are taking it towards the direction of light. So it's negative, minus V. And here U, object is somewhere, it's here. So we take this distance towards this direction. From this point, it's in this direction, opposite direction of light, we take it as positive. So direction of light, we take it as negative, and direction of light, we take it as positive, right? So moving into our equation again, lens formula. In this scenario, we can apply now. Let's write it 1 over V minus 1 over U equals 1 over F. Considering only this scenario, V is negative, U of course positive, but here we have a negative value here, minus. So it's like this. Then we have lenses in contact. Let's say we have two lenses, say now F1 and F2. So when these two are in contact, let's say compound lens. If this is F, compound lens focal length is F, then 1 over F is equal to 1 over F1 plus 1 over F2. Another equation you should remember. Basically, when it comes to optical instruments, we have three. First we have simple microscope, and then we have of course compound microscope. Then the last one, it's telescope. Moving into magnification equations of all the optical instruments. Let's start with number 1, simple microscope. Here we have first one, simple microscope normal adjustment, M equals D M over F plus 1. Here dm, we take it as least distance of distinct vision, it's 25 centimeters, right? Moving into special adjustment. Here in the special adjustment, the magnification will be final image at infinity, M equals Tm over F, right? Moving into compound microscope. Compound microscope magnification. Here the magnification we have here the lens closer to eye, it's eyepiece, and here we have objective, right? So magnification is objective is V0 or F0 minus 1. Here V0 is image distance, and just like in simple microscope, magnification of eyepiece is dm over F plus 1, because the final image is formed at near point dm 25 centimeters. So this is the magnification of compound microscope. Now moving, this is the normal adjustment, we are moving into the special adjustment. In special adjustment, magnification, total magnification, here same, V0 or F0 minus 1, but the magnification of eyepiece, it's Tm over F, just like in simple microscope. Moving into astronomical telescope, normal adjustment, final image is formed at infinity. It's a simple equation we have, M equals F0 over Fe. F0 is image focal length of objective, and Fe eyepiece focal length, F0 over Fe. In special adjustment telescope, M equals F0 over Fe 1 plus Fu. Here the final image is formed at near point. So here D 25 centimeters. Moving into I defects. Basically, I defects we don't use that much of. We have only one equation, 1 over v minus 1 over u equals 1 over f equation. Here we need to identify key points. Here it's that we have far point, basically infinity, and we have near point 25 centimeters. Here we have I. So if infinity is not visible and near point is visible, we call it short-sightedness. And if near point is not visible, infinity is visible, we call it long-sightedness, right? So here basically what we do is let's say we have near point here 50 centimeters and we have far point here 2 meters. So if we need to watch infinity, we create image of infinity at 2 meters. And if we need to watch, if we look at 25 centimeters but we are unable to watch it, so what we are unable to see it, so what we do is we create an image of 25 centimeter at 50 centimeter. That is basically what we do is we apply lens formula and we find the answers for f, right. Moving into the last part, prisms. Third part, refraction through prisms. Basically you should know these angles actually, I1, R1, R2 and I2. And of course we have something like this. It was moving towards this direction, but finally it was moving in this direction. So the deviation is this capital D, right? We have to have equations for this. We need A, capital A, prism angle A equals R1 plus R2, total deviation D equals I1 plus I2 minus R1 plus R2, or else you can write it as minus A. D equals I1 plus I2 minus A, likewise. And if this is symmetric in minimum deviation situation, minimum deviation means it's something like this. Say now we plot a graph with I and deviation, so we get a graph like this. So we have a minimum value, so we call it dm, minimum deviation. At minimum deviation point the system is symmetric, the ray diagram is symmetric. Basically it's like this, I1 equals I2, so and R1 equals R2. So A equals 2R, then R equals A by 2, then dm equals 2I minus AI equals dm plus A by 2. So by using this we can write the refractive index of prism as sine dm plus A by 2 divided by sine A by 2. That's the equation we get from this. So these are the all equations we have in optics lessons we have. So by applying these equation, then only we can do questions. You have to remember almost all the equation. Remember that. I hope you went through the equations now. You must know almost all the equations. Remember that you cannot skip any of those equations because it's a must. You have to remember almost all the equations. If you feel like that you do not know the equations, that means you haven't followed the theories that much. So what are the things that you can do? Remember almost all of these equations. Yes, you can recall the equation by writing it down, for sure. That's possible. That's one of the possibilities, one of the things that you can do. But still, you need to do questions in order to remember the equations, because then only you will know how to apply the equations properly. Yes, knowing the equation is the first step, but definitely when we are doing questions, actually you should know how to apply the equation, right? First you should know the equation, that's there, okay, write down, okay, you know the equation, that's perfect. But you should have the ability to apply the equation for sure, right? So get the equation and try to find the questions from that. Yes, you can go through the playlist I've given and you can find the questions. So you try that question and find similar type of questions from your tunes, through videos and all that, and you can find questions from books as well. So that's the method. I hope you understood it proper.